One of the things that's missing from the supply chain or designers of buildings is the ability to actually give the data back to clients so they can actually make better decisions. And what I mean by that is, should they want to make decisions that work short term but don't work long term? Where's the analysis? Where's the whole of life cycle cost model? Where's the energy cost over time? These things can be done very quickly from a digital model. It can say, okay, you're going to save this now, but if you actually spend a little bit more now, your bank balance would be 100x after 5, 10, 15, 20 years. And as well, moving people into the realm of considering that the building is around for 50, 60 years. It's a little bit of a mindset shift that needs to happen there, I would suggest.
Before we go into the podcast, if you could just go and rate this show on whichever platform you're listening to it, it makes a huge difference to the podcast, the amazing conversations we get to have, and the incredible guests we're able to get on the podcast. So it's probably not something you would think about, but if you could just go rate the show, follow it, or share an episode, it does make a huge difference to the show. Thank you so much. In a world increasingly facing the challenges of climate change, with the Building Green podcast, we will dive deep into the intersection of architecture, design, urbanism, and environmental responsibility. I'm Ladina Schipp, your host. I've been an architect and building site manager for the past 10 years. During my studies at ETH in Switzerland, as well as in my working environment, I've had many touchpoints with sustainability, like many of you, I guess. I've also learned to question what I've been told, which is why I decided to go deeper into the topic and uncover what sustainability actually means. My mission is to highlight the transformative power of sustainable architecture, not just as a practice, but as a catalyst for broader societal change. Subscribe for more of our content and enjoy the show. Today on Building Green, I'm thrilled to welcome Paul Paterson, founder of Elevation Sustainable Building Solutions. Paul has years of experience in engineering, construction, and sustainability, spanning back to his roots in Scotland. His passion for energy efficiency and reducing the carbon footprint has shaped his impressive journey across the globe, from major projects in the UK to the rapidly developing landscape of the Middle East. In this episode, we're going to explore how Paul has identified inefficiencies in traditional building design early on and pushed for energy simulations to really drive savings. His mission at Elevation is to place energy and carbon reduction at the center of building design, construction, and operations. And what about the truth about sustainable buildings? At the end of this episode, Paul debunks the myth that they cost more, explaining how optimized designs can actually reduce capital and operational costs. Paul's focus on closing the performance gap in building operations and his dedication to real-world energy savings make this an exciting and valuable conversation. Welcome to the show, Paul. Thank you so much, Paul, for joining me today on Building Green. Super excited to be talking to you today.
Thanks for having me. Pleasure to be here.
Paul, you've had an impressive journey from working on huge projects to starting your own company. Tell me your story and what's the first experience that got you interested in making buildings more sustainable?
I started my career back in 2003 back in Scotland, where I studied in the topic of building services engineering at university. The building services engineering, some may know that as MEP, mechanical, electrical, and plumbing. And my job, as my career started, was to start to learn the ropes and be involved in the design of heating, ventilation, air conditioning systems, plumbing systems, drainage systems, electrical systems, essentially everything that went into a building. We'd be working with the architect to design, coordinate, and specify. And as I kind of started to learn from some really highly experienced engineers, and I'll never forget that kind of early part of my career, during the mid-noughties, noughties of this makes me sound so old, but anyway, they revised the building regulations in the United Kingdom, and they made some changes and required more thought towards energy efficiency. And I was kind of looking around both what our business was doing and what I saw in the market, and I saw a focus on kind of rule of thumb type approaches and how things were being designed. For instance, if your fan had to be sized. If you calculated that it needed to be X times big, you would perhaps specify it as X times 1.25 to add margin just in case something went wrong. And that was the way things were happening. And I kind of thought to myself, well, that's a bit odd, because surely if you're specifying and designing and installing all of this extra stuff that you don't need, that's going to have an impact on your energy. And I got more and more interested in that topic and looking at ways to simulate energy and simulate buildings at the design stage, and started to propose different ways things should be designed in order to, first of all, simulate them and then get them sized more towards the ideal digital simulation. I wouldn't call it perfection, but kind of starting to focus on energy rather than just on the engineering and component. So as I get more involved in that, I started to work with one of the major software providers in the UK, who are also based in Glasgow. And we did some nice research and development work where we were looking at ways to analyze, predict energy and carbon for a new building project at the design stage, and then see if we could actually deliver that once the building was built and created. And what we started to do was work all the way through that chain, from design through to construction through to operation, and use some digital technology to prove that the theory works and to prove that you could actually both predict and then deliver some high-end energy and carbon savings. So that's always been my interest, trying to make things as optimally designed as possible, reducing waste. I just like that idea and I like that approach. So in the mid 2010s, after that part of my career was over, I decided to come to Dubai firstly, and I started working for a contracting firm in Dubai. And so I went from a consulting firm. I was now in a different region, totally different world, working for a mechanical electrical contractor. I was based in where there was a mega project in Abu Dhabi at the time. I was doing a commute, and I kind of got exposure to the other side of the world. So understanding, okay, it's all very well and good specifying and designing and trying to do these things, but someone's got to actually build it and figure out what's going to happen. So I got that extra experience, and my career kind of meandered a little bit through that contracting business. I then ended up I was in a consulting business for 4.5 years, GHD. Again, moving kind of up the ranks and getting more involved in more of the wider range of project delivery rather than just the engineering component. And it was through that journey that I started to keep thinking about the old days, not necessarily with a small tear in my eye, but especially in the UAE, as they geared up for COP28 in 2022, sustainability was becoming more of a real tangible requirement. It was becoming clear the size of the prize. The built environment was kind of questioning itself. More and more people were starting to understand that the problem that people had been talking about since the early 2000s was still a problem. And I decided that to go back to where I first started and focus on that specific problem and answering the question, how much energy should my building be responsible for? How do I make sure I deliver on that target? And how can I continually improve on that target, all the while trying to meet carbon emissions that are set locally, nationally, and globally? So it's through that origination story that I now find myself trying to continue to do what I started back in 2006, albeit under my own steam and kind of a little bit of more of a focused direction.
It's a beautiful story. Why did you move to Dubai? Was it for professional reasons?
Yeah. I kind of wanted to expand. I wanted to expand my career, try something new. Both myself and my wife had decided that we wanted to kind of make a change in our lives, and we thought, well, let's head over to where there's a lot of building happening, so there's a market for the types of services that we do. So yeah, it was more of a let's just go and expand our horizons a little bit was the idea.
Did you feel they were more advanced when you first arrived?
I kind of thought they could be. But this is back in 2015. I did find that maybe not quite as advanced as what we were thinking, definitely not as advanced as what was happening in the United Kingdom. So there's been a a kind of slow process with regards to sustainability in this region. I think still trying to move away from specifically focusing on just compliance to code requirements and that kind of regulatory landscape to more thinking about, okay, how do we push the boundaries a little bit more? How do we deliver more rather than just meeting the kind of bare minimum of what the government targets are?
That's interesting. So, Paul, then you founded your company Elevation. What's the mission of the company, and how do you plan to make a difference in how buildings are designed?
What we like to say is we're here to drive a paradigm shift in how buildings are designed, constructed, and operated, and that's moving to place energy and carbon central to the story from before a pen gets put to paper till after that space is being used by the public or whoever the stakeholders are. So it's moving away from simply thinking about the energy consumption of a building as an afterthought or something you might only find out about after you've got a year's worth of bills, perhaps 5 to 10 years after you first thought about constructing the project, to putting this right to the very, very, very center of the story. And I think that provides a lot of value on a number of fronts. Firstly, it enables our clients, developers, investors, real estate owners and operators to drive down capital expenditure costs, because if you're thinking about energy and carbon at the start, you can actually reduce the amount of systems and services that you need. You can then unlock further value during the operation of your asset, because the better the systems are tuned and matched to the actual building requirements, the less energy that these buildings will consume. Therefore, it will cost less to run. The flip side of that is the changing, evolving landscape of carbon emissions. So it's not unrealistic to think that at some point in the not too distant future, carbon will be taxed. So if you're not controlling your carbon emissions contribution from your real estate assets from the very start of your project, you're storing up a problem and you're adding risk to your portfolio. So ultimately, it's about maximizing value and minimizing risk. And how do we do it? Well, we work again with developer clients before projects are created, or we work with designers who are designing projects. And we create digital models of their buildings. We, using our engineering knowledge and our deep experience of building services, or MEP, should anyone from this part of the world be listening, and recreate the systems and services and the automatic controls and everything that's going to be created in that building in the digital environment, and allows designers to optimize, analyze, and figure out best for project design solutions in order to, again, minimize the energy and carbon cost of these projects.
You probably know I'm an architect, and from the perspective of an architect or for an architect, what are like the key metrics that you analyze and that you're looking for in the design process?
First and foremost, we're following the legendary energy hierarchy. So it's all about reducing the need for energy first, then improving the performance of energy consuming equipment. And then once you've done all that nice stuff, then perhaps you're also going to be looking at offsetting those energy requirements with renewable systems. But we're very much a proponent of trying to move the market away from considering a project that is going to be, let's use the new build market. Let's try to move away from, okay, I want a new build project and I want it to be LEED Platinum. Fine. However, what you're actually requiring is you're requiring your new project to have an energy cost, an energy usage intensity, EUI as it's shortened to, of a certain value that either fits what the regulations are going to be saying, or it fits in your global portfolio targets, because you're decarbonizing across your many assets. So the key metrics for us is energy use per square meter per year. That's the number that we're seeking to propose to clients, and that should be the kind of North Star of a project and help guide the decisions. And of course, how that number comes out, the lower the number, the better. The lower the number, the better. You've got better fabric U values. You've got good shading on your facades to offset any of that solar gain, which you don't want. You perhaps getting some nice cross floor natural ventilation should the prevailing climate and wind directions allow. And then you're looking to kind of push the boundaries a little bit and what kind of systems and services you're going to be installing on top of that.
Is there like any key element that's often forgotten that really drives that energy consumption lower, besides of passive architecture like size and positioning of the windows, I guess insulation materials, shading systems, and of course efficient devices? Is there anything that you've seen with your experience that's often forgotten by architects or other stakeholders?
I don't think forgotten. I think there's a lot of good movement in terms of trying to do that passive design space. I think the struggle that a lot of projects have is the pace. So it's difficult to start to code in these measures and these kind of nice design decisions because you're kind of in a 4, 6, 8 week time frame to try and push as hard as you can. And of course, in this region, so I'll speak specifically about the region I'm in, which is the Middle East, it's difficult to look at kind of natural ventilation solutions because, okay, well, you may be able to bring in some air from the outside at certain periods during the winter. It's not really that much. And you kind of find that the cost benefit analysis doesn't really marry up to that.
Okay. And Paul, you've talked about the performance gap in buildings before. Can you explain what that is and how we can close it to make buildings truly energy efficient?
Yeah, so the performance gap has been a term that's been flying around for many, many years. And it essentially says that a building, when operated, can be using 2 to 5 times the amount of energy than what was predicted at the design stage. So taking that as read, that's based on data, that's the Chartered Institute of Building Services engineers who have got this definition for the building performance gap. The theory then comes back to considering that if we are trying to reduce the amount of carbon in the atmosphere in order to maintain temperature rises to within a band that's more than 1.5 degrees Celsius now, more than likely. But if you're trying to reduce that number of carbon emissions, and you have a built environment that's responsible for 39% of global carbon emissions, then it stands to reason that you have to be considering that your projection of your energy cost of your buildings at your design, you want to keep that maintained through to your operation, or you want to be very, very clear on any expected variance or any reason for the variance. Because if you're not, then we're not actually meeting our strategic target, our global strategic target, which, as I said at the start, is reducing the amount of carbon emissions. So the performance gap can be caused by a number of things. It can be caused by inaccurate projections at the design stage. And one of the ways we see this manifest is if a consultant is doing an energy model using a compliance approach, an ASHRAE 90.1 model, anything specifically just focused on a compliance requirement and then reports that as the energy use, that's incorrect. That's not the way it should be done. There's more nuance to it and there's more in-depth analysis needed. That can underestimate it. Another way it can be underestimated, there can be a variance, is if systems are oversized. And I mentioned that earlier. So if a system is oversized, take for instance a ventilation system or a cooling system. If it's oversized, what that's really meaning is it's working at part load for, not to get too technical, but it's working at partial load for most of the year. And the more oversized it is, the more inefficient that part load performance is. So you end up using more energy than what you would expect. So oversizing is a contributing factor. There's unforeseen or untracked or missed changes during a construction process. Of course, construction always changes. It could be there's additional systems installed. There's things that we haven't known about. And then there's the other ones that you could reasonably expect, which is perhaps the building is going to be used for something different. Or perhaps the original anticipated occupancy profiles for the building have now doubled. Maybe there's twice as many people in the building. So these are going to have dramatic effects on energy. But the key message is we've got to be able to firstly have an accurate prediction. And I say accurate based on the level of information that's available. But we've got to be able to track that all the way through the stages and understand any reasons for the variance. This is what we're really trying to get to.
Why do you think are we still at the point where the building industry often designs without fully understanding operational energy costs?
I think, again, back to the pace in certain markets, pace of construction, pace of design naturally means that there isn't a breathing space for this type of thing to be considered. I'm not saying that's right. I'm just saying that that's a contributing factor. I think it's easier to also not look into the future. And again, I relate this to how we actually live our lives. Is the immediate need is to do something quickly and to get it off our desks and to move on to something next. As humans, we're not really too super interested in factoring in the long-term effects of decisions. And I know as well, someone's going to tell you that you're going to have to maybe spend another couple of dollars right now to save $100 5 years down the line. Still, people will say, oh, you know what, I'll just keep the money in my pocket right now because 5 years down the line is a long way away. So there's a lot of these types of mental challenges in terms of the kind of human condition. But I think one of the things that's missing from the supply chain or designers of buildings is the ability to actually give the data back to clients so they can actually make better decisions. And what I mean by that is, should they want to make decisions that work short term but don't work long term? Where's the analysis? Where's the whole of life cycle cost model? Where's the energy cost over time? These things can be done very quickly from a digital model. It can say, okay, you're going to save this now, but if you actually spend a little bit more now, your bank balance would be 100x what it is after 5, 10, 15, 20 years. And as well, moving people into the realm of considering that the building is around for 50, 60 years. This part of it is the key part. This 6-month design window is locking everything in for a 60-year duration. So yeah, it's a little bit of a mindset shift that needs to happen there, I would suggest.
If you're enjoying the show, I have a small favor to ask that would mean the world to me. By rating and sharing the podcast, you're helping us grow and spreading our mission of making sustainability really desirable and cool to a wider audience. Besides of that, imagine impressing your colleagues with the latest insights on sustainable architecture. So make sure you follow the podcast and become the most informed in the room. Thank you so much for your support. Where do you think do we have more potential on saving energy in the construction process or later in the running the building?
As I mentioned, there's various aspects of getting that design right at the start and getting that projection right at the start. But you're going to have more opportunities when the building is running, because you're going to have, as I say, decades of operational costs where every kilowatt hour that you potentially save is money straight back into the bottom line of the asset owner or asset operator. But here's the catch. You don't really know how much energy is the right amount of energy for your building unless you've went through this process. And again, let's take the new build. You've got a design that gets created. There's estimates on how the building is going to be used, etc. But all your systems and your services and all of that key hard stuff is going to be coded into this model. It's going to be updated during construction. And then you can tweak it based on should, for instance, your building no longer be a restaurant. It's been turned into another, I don't know, a commercial office, a terrible example. But you're going to be changing the parameters of this theoretical projection as more information becomes available. But what that's going to give you is the technology tells you what is your optimal energy use for the building. Then that becomes your baseline. So then you're able to use that every year to review how your building's actually operating against what your baseline would be. So that's the kind of the key value of going into that detail at the design stage. And then you can unlock those significant savings as you operate your building.
And can you compare in terms of energy efficiency in Dubai or in Abu Dhabi, a small single family home with a big hotel tower or office tower?
It would be a challenge, but the way that the metric that would be used is back to the EUI metric. So that kilowatt hours per square meter per year would be a metric that for similar types of buildings you could then use to compare like a league table. But generally you would have your league table of villas. You'd have your league table of commercial office space. You'd have your league table of hospitals. You'd have your league tables of educational facilities, because you'd want to compare within categories, because each one of them will have drastically different energy profiles and energy requirements. Hospitals, especially laboratories, etc., etc. So you would assign them to categories, and then you'd want to refer to international benchmarks, or even better, if you're in the UAE, perhaps looking at starting to benchmark, baseline your existing assets. So you have something to compare against, to measure against, to improve against.
And can we say which category is the most inefficient and which one is the most efficient per square meter?
The numbers vary. So let's look at villas. So the villa, the home that I'm in, my number VUI is around 160 kilowatt hours per square meter per year. So if you know the area of the place where I live, you times it by 160, and that's how much energy costs or electricity I'm going to have to purchase in a year to keep it cool. More modern villas, homes that they're building here are pushing down to south of 100, so into kind of 90, 95 area. So like a 60%, 70% increase in what would have been built 15 years ago. We're now seeing the market being able to produce now, but it's difficult to say for any category of building. You would have your bell curve, you would have your kind of median performance, you'd have your really, really bad ones, and you'd have your really, really good ones. I haven't yet seen any perhaps pattern that would say that this is less efficient building type than that. You can say that building type uses more energy than a building type like this. You can say that, but I don't think you can say that it was less efficient.
So we can say either you're designing or building a villa or a hospital or an office building, there is no excuse on not having it or building it very energy efficient.
Zero excuse. Absolutely zero excuse. And there's various guidance coming out. Again, I always turn my eye to the UK because I think they do lead the way in terms of all this types of discussion. UK and Europe, but UK especially. They now have a lot of documentation out there which is specifying this EUI number for various types of buildings. And that is where the future will be. It won't be that you just have to meet this code or you're going for LEED Platinum. It will be okay. You're building a new home. Here's the energy performance number that you have to achieve. That's where things have to head.
So, Paul, you've talked about how getting a LEED Platinum certification isn't really enough to truly make buildings sustainable. Can you explain why that is and what you think is the key to designing buildings that are really good for the planet?
I like to call it the LEED Platinum paradox. What I mean by that is just because you've ended up with a LEED Platinum building does not mean that you have advanced the goals of the built environment, which is to decarbonize and support global decarbonisation goals. And why I say that is that you could get a LEED Platinum building, but still have an inefficiently performing building. You haven't closed the performance gap because potentially that's not something you've looked at. Your projections might not be accurate. And also, although the LEED scorecard does have a lot of weight attached to the energy performance, there's also a vast amount of other credits available across the materiality, site location, and all these other categories. So you could actually drop some credits in your energy performance aspect and pick other ones up from different categories. There's nothing to stop you doing that. So you could have LEED Platinum, but you might not have an energy efficient building. And it also doesn't prescribe to these EUI targets either. And I also don't think it mandates, I'm sure people will jump on for me saying this if I'm wrong. I don't think it mandates using energy performance modeling. I think you can still do a kind of more of a manual prescriptive approach. So there's a few gaps, but I do also like to caveat with the LEED movement and all of these green building movements has been the tide that has risen all ships. It has been a good thing. My argument and my position is it's been great. However, we need something more robust and we need it more focused on the carbon targets and the energy targets, which are related to science-based targets, which again are related to how much carbon you're trying to reduce.
Embodied carbon is a big issue in construction. What are the biggest challenges in reducing embodied carbon, and how can the industry start tackling this more efficiently?
I think this is a data problem. Embodied carbon is challenging. The supply chain isn't quite there in terms of transparency of data across the piece. So you're going to have gaps in terms of understanding the carbon emissions associated with products that you're going to be using to build. That is improving, but it's a challenge, and it's a relatively new thing. So there's going to be time needed before all of the products that are used in the construction sector have environmental product declarations. That's going to take time. So that's the biggest challenge with that part. That said, there's still some fantastic databases out there. There's still ways to get very, very good approximations. Software like One-Click LCA as an example accesses global databases, and that it gives you access to some good data. But region to region, I think that there's some gaps in the data, and I think that it's more advanced in the actual construction part, steel, concrete, all of the stuff that creates the building. The mechanical and electrical side, I think, again, is lagging a little bit behind the other parts. So it's progressing, but there's a challenge there.
For those of our listeners who are not familiar with what embodied carbon really is, can you break down what it is and why it's such a huge problem?
You're testing me deeply here. So embodied carbon for a material would be the amount of energy that's used to create that material. So say it's a glass, you're going to have a process. Say, for argument's sake, it's a 10-step process. You're going to be getting some resources together. You're going to be taking them to a factory. There's going to be some smelting involved. There's going to be a furnace involved. There's going to be transportation involved. All of these activities would burn fossil fuels generally. So all of those activities are all of the fossil fuels that are burned to create your pane of glass would be a certain amount of kilograms of CO2. Well, it's called embodied carbon. It doesn't mean it's inside it. It just means that that product has cost the planet, in carbon terms, however many kilograms. And then when it comes to those types of materials, you have providers who are helping to solve these problems by either using more circular economy approaches, or perhaps electric furnaces is a good example. So perhaps it's fully renewable systems. There's new technology there. Instead of burning gas, fossil fuel to get your high temperatures, there's now ways to use renewable electricity to do the same, and that would reduce the embodied carbon of said product.
Are there any materials that you really ban from all your projects, or some materials that you like to use as alternatives and that are often underestimated?
In terms of things that are banned, well, they're banned either by regulation or again by some of these green building scorecards. So it's the classic hydrofluorocarbons, formaldehydes and paints. Those are the ones that shouldn't be used. I do like the move to more low carbon concrete. And one of the people that we've been working with here in the Middle East is providing a graphene solution. So they're creating graphene, which is a form of carbon. They're creating a very thin carbon. I'd have to go back through the website, but they're creating carbon from waste products, and they create a carbon solution which, when added to a concrete mix, enables that concrete mix to be stronger, to dry quicker, to use less water, and to require less concrete volume. So it's a way to decarbonize the amount of carbon needed in concrete. So there's a lot of these new technologies appearing, these new startup technologies that are now starting to become more and more of an option for builders as well, which is super interesting to see.
Do you see a huge shift in the importance or the amount of efforts that go into research for new materials?
I've noticed a shift in the last few years. I sense that there's a lot of work to be done, especially around, like I say this relatively tongue in cheek, but I do say it with actual seriousness as well. And when I still go to conferences and I see discussions about how building information management, how BIM is going to change the construction landscape and change the way buildings are designed and delivered. And I say to either people I'm sitting next to, if they'll listen to me, I'll say to them, I've been listening to the same things here for the last 20 years. It's the same presentations. Why are we still talking about it? Why is it not? This is what's happening. This is the next thing. Our industry is a long-term laggard. I think there's the legendary McKinsey statistic that our productivity is 1% growth, which is 2 percentage points less than just the base global average. It's pretty outrageous. We like to do things extremely slowly. So the pace and the rate of change is not fast enough. But I think that complaint will be going until the end of time. There's opportunities for us in new methods of construction, off-site fabrication, doing things a little bit differently rather than bringing everything to a site and having 100 people assemble and all the quality problems with that and all the risks and the safety. Is why we're not prefabricating off-site more and bringing it and just assembling it. There's various movements and smaller pockets of the industry. The guys in Saudi, I think, are more heavily proponents of this. So I would summarize it that not enough, but there is some, but change takes time in construction.
You've worked on a lot of different projects. What's the biggest lesson you've learned about making buildings more sustainable?
There's a challenge here in terms of communication, coordination, and kind of transfer of data, risk and liability. When I mention risk, I mean it's easy for designers perhaps not to push the envelope because, well, what if you get it wrong? No one's going to thank them if they get it wrong. I think when it comes to construction and the construction process, I think there's certain gaps there in terms of how that drawings and procurement and that coordination piece is coming together. And I think that can impact sustainability because, again, perhaps you're not linking what's being purchased or what's being procured back to what you've actually assumed in your energy model. So there's gaps and discrepancies that can start to build from there. Yeah, those are kind of the key areas off the top of my head.
Yeah, I mean, the building process is already very complex. There is lots of different stakeholders involved, lots of requirements. So everybody likes keeping it as simple as possible. So if we now add this challenge of sustainability and questioning everything from the first moment on, it's good to have someone in the team like you that knows what he's talking about, that has his tools and stuff to really go deeper into those questions. and then you can solve them for the designer, help them solve it, and not just like leave them in the dark with a few more questions about sustainability.
Exactly. But I think it has to be like focused. And again, it's not just sustainability for sustainability's sake, but one of the things we're actually looking at is, say for instance, you're designing a net zero energy project. So that's even more critical, because what that's essentially saying is that once you've constructed your building and after 12 months of energy consumption, you're going to look at your meter bills and you're going to say you've used X amount of energy. And then you're going to double check that against your renewable energy production. And you're going to want to be sure that the amount that you've used is less than the amount you've produced. If you don't do that, you haven't got a net zero energy project. And why I'm linking it to that is because that again comes back to a super accurate net zero energy prediction at the design stage that enables the sizing of the renewables. But there's then that strand of information, or all the assumptions that have been made in that projection, have to be continuous all the way through a construction process. So we're currently working with some clients to try and facilitate a more easier process. So again, when someone does a drawing that involves energy consuming equipment, or when somebody procures something that is energy consuming, there's an easy way for that to be automatically checked against your inputs, and a kind of early warning system. You have a problem here. This should be okay. You're within a certain percentage range of what this value should be. And I'm thinking like system efficiency or power rating of equipment, because if you start to get those things wrong, your client has significant risks in terms of actually delivering what you were supposed to deliver. So that trying to fill that gap with clients and contractors to make everyone's life easier in order to deliver the final product.
Paul, I have one last question for you. Can you debunk one common myth related to sustainable building?
They don't cost more. Why?
You would be surprised by how often I get this answer.
They don't cost more. They don't cost more. Unless you're spending all your budget on certifications. And it's back to, what do you mean by sustainable? So let's link it back to energy carbon targets. My position, and I will put to anyone who listens, is if you've got a robust energy target, you've projected and run an advanced energy performance model, you've used that to inform your system's plant and equipment sizing, you're going to end up buying less than what you would have if you didn't go through that process. If you're buying less, it costs you less. It costs you less to build, and it costs you less to run. Sustainable buildings, in terms of low energy and low carbon, shouldn't cost more. And if people are telling you they're costing more, well, give me a call. I'll give you another. I'll give you another viewpoint.
Thank you so much for this great answer, Paul. It has been a pleasure talking to you. If people want to give you a call or follow your work in general, where can they find you?
Yeah, go onto our website, elevationcarbon.io, or look me up, Paul Paterson, on LinkedIn. I generally post a few times a week, which I'm sure some people might be getting bored of, but I should continue to do it for as long as I can. So yeah, look me up on LinkedIn or check the website.
I'm going to leave the links in the description of the episode. Thank you very much, Paul.
Thanks so much. An absolute pleasure. Thank you for having me.
A huge thank you for listening. Make sure you subscribe to the show wherever you listen to the podcast to support me and so you don't miss an episode. And while you're there, I'd also be so grateful if you could rate and review us. If you have any guest suggestions or any feedback, you can find me on the socials at LadinaShipf. Thanks.